Welcome to the Bio 111 lab. In this first lab, we're going to cover the scientific method. I want us to start to think about science as a process and not just the collection of facts in the textbook. The scientific method is how we do science. It's how we know that the facts in the textbook are right. This first lab is fundamental to everything that we'll do this semester. I'm going to start by giving you a brief introduction, and then we'll have some activities that we'll do as we move through this lab. These are the steps of the scientific method. Science starts by scientists making observations and asking questions. Good scientists retain their childlike sense of wonder about the world, and they continue to ask the why and how questions even as adults. For instance, I have a goldfish pond in my backyard, and in the summer I like to go out and feed the fish. I'll throw out fish food and they come up and eat it. I can dangle my feet in the pond and they'll come up and nibble my toes. They'll follow me around. They're wonderfully interactive pets to have. But in the winter I noticed they won't eat the food and they won't come to my toes, and they'll just hang there motionless in the water. In fact, they'll let me pick them up and take them out of the water if I tried. So as a scientist, I start to ask, what's going on in the winter? Why are they going dormant? Is it the cold? Is it the short days? Is this necessary for reproduction or survival? What would happen if we changed the temperature of the water out of season? For these questions to be useful to science, we have to test them. But before we test them, we need to come up with a hypothesis or educated guess as to what's causing the phenomenon that we observed. It's not intuitive to make a hypothesis before running a test. After all, most of us would just try testing what's happening with the fish and see what we get. But let me give you an example that will help you understand why it's so important in science to make a hypothesis before you run your experiment. The famous physicist Richard Feynman once told a story about seeing a particular license plate. I think in the example that he gave, it was ARW357. And he said to his audience, he had quite a sense of humor, but he said to his audience, "It's amazing, out of the millions of license plates in the state, I happen to see that one." Now, it's not really amazing. We all realize that whatever license plate he saw would have been one out of many millions. So it's only when you hypothesize or predict that you're going to see something in advance and then you actually see it that you know you're onto something. That's the reason why we need to make a hypothesis. In the case of my fish, I suspect that it's the cold that's making them go dormant in the winter. So my hypothesis is that the cold is causing them to become dormant. If after testing whether it's the cold that causes my fish to go dormant, if my results do not support that hypothesis, then I'd need to think of a new hypothesis and run a whole new test. So you've made an observation, come up with a question, formed a hypothesis, and now you're ready to test. There are several factors that you need to consider before running an experiment. So you've made an observation, come up with some questions, formed a hypothesis, and now you're ready to run an experiment. Before starting your experiment, there are several variables you need to think through in order to carry out your experiment accurately. The first variable that you need to think through is the independent variable. The independent variable is what you will manipulate or vary in the experiment in order to study the effects of that independent variable. In the case of my fish, since I suspect that it's the cold that's causing the fish to go dormant, the independent variable that I'll test will be the temperature of the water. The second variable is the dependent variable. This is what you'll measure to get the outcome of your experiment. So I can vary the temperature of the water that my fish are in, but what am I going to measure to get an outcome? I might look for movement of the fish, or I might try to measure heart rate, or a simpler thing maybe would just be to measure the breathing rate of the fish. I can spell out a predictive statement that involves my independent and dependent variables in a statement like this. So I have an if-then statement with something about my independent variable in the first part by the if, and something about my dependent variable in the second part by the then. So if I lower the temperature of the water, temperature is my independent variable, then the fish will breathe slower, and the breathing rate is my dependent variable. Embedded in this statement is what I think is going to be the relationship between my independent and dependent variables. In other words, I'm not just saying that the temperature is going to affect the breathing rate of the fish. I specifically think that lower temperatures will cause slower breathing in fish, and conversely, higher temperatures will cause faster breathing in fish. Now it's just a matter of setting up and running an experiment with multiple trials and a controlled variable. In this lab, I'll walk you through how to do that. For now, let's just imagine that we've run our experiment and I have some results and we've created a graph. Typically when we make graphs in this class, we'll see the independent and dependent variable relationship on the axes of the graph. So the y-axis of the graph has my dependent variable, again, number of breaths per minute in these goldfish, and the x-axis will have the independent variable, which is the temperature for this experiment. Finally, you'll draw a conclusion about whether or not the results of your experiment did or didn't support the hypothesis that you came up with before you ran the experiment. Okay, so you will conclude with my results support my hypothesis or my results don't support my hypothesis. It's okay if you run an experiment and your results don't support your hypothesis. You're not going to get a bad grade on the lab for doing this. It's extremely important that you don't change your hypothesis after the experiment. It's just as important to find out what doesn't cause my fish to go dormant in the winter as it is to find out what does. So there you go. This is the basic process of science. Asking questions, running tests, and coming up with explanations for how the world works. In the activities that follow, I'll guide you through a very simple experiment where we'll look at the factors that affect how fast Alka-Seltzer dissolves. Then you're going to use what you've learned to design and carry out your own experiment. In this first lab activity, I'm going to show you how to set up a very simple experiment testing the effects of water temperature on the dissolve rate of Alka-Seltzer. Now, with any of the hands-on labs in this course, the first thing you're going to need to do is find yourself a space where you can work. You need to have plenty of room to spread out. It needs to be safe. You need to be away from small children and pets, and you need to make sure that you give yourself enough time to complete the experiment that you start. For this particular experiment, you're going to need a measuring cup and some water. It will help if you have several cups that you can run the experiment in. You're going to need a thermometer that can measure, ideally in Celsius, between 0 and 100 degrees Celsius. It's okay if it's in Fahrenheit, but then that would be between 32 and 212 degrees Fahrenheit, so a liquid thermometer. You're going to need some Alka-Seltzer tablets, and you are going to need a stopwatch. I'm going to use my phone for my stopwatch. Also, you are going to experiment with your water temperature at room temperature, hot and cold. So you will either need some ice to chill your water, or you will need to have put some of your water in the refrigerator in advance. Okay, so I'm just going to show you how to collect the data. I'm not going to show you the parts of the lab that require the cold and hot water. I have room temperature water here. I'm going to start by putting my thermometer in the liquid. I have about 1 cup of water. This is, again, roughly room temperature. I'm going to let it come to equilibrium and get a reading from it. This is about 32 degrees Celsius. I'll record that. Okay, and then I'm going to take my Alka-Seltzer, I'm going to open it and get 1 tablet out. Now, for this particular experiment, it's important that your tablets are whole. So if you get a broken tablet, just put that aside, don't use it. Make sure you've got a whole tablet, okay? And then I'm going to get my stopwatch ready here, okay? And I'm going to put the Alka-Seltzer in the cup and press the start button at the same time. And I'm going to let that dissolve, and I'm going to watch it as it bubbles, and I'll stop my stopwatch when that Alka-Seltzer tablet completely finishes dissolving. I've got a little bit more. Okay, so I'll stop my stopwatch. I have 38 seconds there, so I'll record that amount. Again, I'm going to repeat this experiment using 3 trials at room temperature, 3 trials with cold water, and 3 trials at hot water, and we'll take the average of those, okay? Once you have your data collected, I'll show you how to graph it.